hard when you got like a whole bunch of kids so they're all. Let's see. All right, now, so there's a couple concepts that I want to like go over from this, and then we'll talk about the actual problem itself. What's going on in there? What do you see? First thing you should notice there, Sade. And you weren't here, so you weren't here Monday or Tuesday. Well, we did Monday. Nobody can explain what I'm doing. Circles. So. What do you see? What should you notice in this? There. So these markings mean parallel lines. Quite a few people, not on the last quiz because you didn't have to explain anything, but on other quizzes, are saying, and again, maybe you understand it and you're just not able to explain it, but people are saying something about congruence marks. Those are not congruence marks. Congruence marks will just be one little straight line. Those are lines telling you, or those are symbols saying these four lines are parallel. Anytime you see parallel lines, something should immediately be triggered. What is that? How? Take a guess. Parallel lines. First thing you should think of when you see parallel lines. Not for the answer to this. Like when you see parallel lines, first, I mean, I can't even think of anything else at all, really. It's probably the only thing, but certainly it's the first thing. What's red? You're right. Well, they don't touch. That's the definition of it. Like, I mean, this is a concept related to parallel lines. So kind of that's like saying with a right triangle, you guys always say, oh, well, 90 degrees. Well, yeah, that's the definition of it. But what should jump into your head is a squared, b squared, c squared. So that there's a concept that should jump into your head. Congruent, not even similar. The angles are congruent. You've got a whole bunch of congruent angles in this. Oh, he is here. You got to go. Nothing. Take it to them. Just give them that. I have to change you. I'm marking as already. Yeah. And it kind of, I mean, just visually, it looks like they're congruent. And again, I told you can't assume things, which is definitely true. But these angles here are all congruent angles. And there's a whole bunch of them. These are congruent to each other. And then I can come over to this side. So the lesson that's not showing up as well as the lesson was this lesson. Oh, that should have Number one. I should have done, although that's here. So it was that lesson. We said if you have two parallel lines cutting through a transversal or a transversal cutting through the parallel line, whichever way you want to think of it, it forms a bunch of congruent angles. The angles here were congruent and the angles here were congruent. Well, the angles here were congruent and the angles here were congruent. Same concept here. We just more parallel lines and more transversal. So all of these, I'll just change colors to show that these are congruent. All of these are congruent as well. Let me just do it. 3 there. And 4 over here. You get a whole bunch of congruent angles. Now, that doesn't come into play with this problem, but you still need to trigger that. I guess the other thing, there is a second thing before we're going to use the problem. When it comes to angles, you have a bunch of congruent angles. So that's how we prove triangles similar. If we were to make this a triangle and continue it up, we'd be able to say that there's a whole bunch of congruent triangles in there because of what reason? There were 3 reasons you could, I'm sorry, similar triangles, not congruent triangles. What was the reason we could say triangles were similar when we had parallel lines? Has to do with what I just did. Two congruent angles means that the triangles have to be similar. And we've already proved, and technically the top angle, if we connected it, would be congruent also because it's going to be shared by every triangle. So again, that's why we could do angle, angle to prove two triangles are similar when it's like one triangle inside of another and there's a parallel line. That was one of your exit tickets in on quizzes. So now going into solving this, here's the second thing that should pop in your head. I'll just tell you this once we get going. Parallel lines, again, it's really because it creates similar triangles. That's the reason. Angle, angle proves the triangles are similar, but it creates proportions. Choose a different color. It creates that yellow line, the proportion that would be created between that yellow line and that green line is the same proportion that would be created between these yellow lines and those green lines. If you have parallel lines cutting through, again, you're creating similar triangles. We know in similar triangles, the sides are in proportion. And then we learned after that, individual sections are in proportion. We don't even have to add things together. So if I created a proportion, yes, with these two numbers, so again, this segment relative to that segment is a proportion. It's the length of one divided by the length of the other. That proportion is going to equal the proportion of the other segments. So that's a proportion. And then I could say, well, that's going to equal 2.8 over the 3.5, which is also then going to equal 2.4 over the x. And you notice we always, if it's on the left, and we always have that on top, 2.4, 2.8, 3.6. If it's on the right, we always have that on the bottom. And there are actually other ways to set it up. Just as long as you're consistent, you'll be good. And now we can solve by cross multiplying. I can use these two to cross multiply. I could actually use this one and that one and cross multiply. The other thing you can do, if this makes more sense to you, and this is how a couple people did it, I could find the scale factor. I could say, well, what am I multiplying times 2.8 to get to the 3.5? So if I just said 3.5 divided by 2. Actually, somebody do that real quick. What's 3.5 divided by 2.8? 1.25. I'm multiplying. So now do this. Say 3.6 times 1.25. And I'll bet you get 4.5. 3.6 times 1.25. What do you get? Did not get 4.5? Huh? Got 4.5. You got 4.5. Yeah, should. So again, a scale factor is related to proportion. Well, that's what a scale factor is, proportion. But that's what we do. So if I take 1.25 and multiply it times 2.4, that would also give me the answer. So you could also think of that problem either as proportions or as like figuring out the scale factor and then using that scale factor to multiply times 2.4 to get to the answer. Any questions on that? Again, that's the EOC related, not the circle stuff. Question? All right. All right, so now on to circle. We got to finish the other circles off. Oh, I need to add one thing on real quick for you. So when we did circles the other day, can use that real quick. So here was so this is like a super fast review of what's going to be on the exit ticket. I'm not even having you solve it out. I didn't really need to do that. But. So if we have a 50-degree angle, and if I want to know, and let's say they tell me that's 10. We said, I want to know what the length of, let's go color, the length of that arc is, the blue arc. And normally there'd be letters and we'd say arc AB or something like that. I'm just kind of doing shortcuts. We said there were 3 steps. Step 1 was what? That is written down. Well, that's later. And this is like this is for all, not just this kind of problem, but like all the problems we did last class. Step 1 was what? Specific, more specific than others. What percentage of the circle are we talking about? What percentage of the circle is that 50-degree angle? Well, what is the measure of the arc in degrees? It's the same, right? If we have a central angle, we said, you guys are starting to worry me a little bit. 50 degrees. Whatever the central angle is, that's what the arc is. Well, we know a full circle is how many degrees? So we need to know what percentage is this arc of 360. What percentage of the circle? I'm going to abbreviate a lot since this is review. So the way we did that, we said, well, to find a fraction or a percentage of parts of a whole, basically, all those things are parts of wholes. We just take the part divided by the whole. And that'll give us a percentage. 50 divided by 360. So that gives me 0.138 repeating as a decimal, or as a percentage, that's 13, we'll round it up. So that arc, the blue arc, is about 14% of the entire circle. It's a part of a whole. That's what a percentage is, that's what a fraction is, that's what a decimal is. All related. They're really all the same exact number. We're showing it different. So then second, we said, well, if it says length, and I did tell you I want to know the length, that was the question, or how long would be the other key. It could, that's another way of saying length. Length or how long meant that you need to use the circumference. You need to find the circumference of the whole circle. If you see that, length or how long, you have to use circumference. That's the only measure of length. Degrees is just a measure of the percentage of the circle. 360 degrees is 100% of the circle. Radians that we learned is also a measure of how much of the circle, what percentage of the circle, not length. The only measure of length is circumference. So we're going to need the total circumference. And then here's a step that I didn't put in for you guys. I added it later. In step 3, you're going to take the part times the whole. So the part, which is going to typically be the percentage. Actually, yeah, let's just say percentage. Because it'll always be percentage. Oh, percentage times the whole. So if the whole is, if they want to know it in degrees, then the whole is 360. If they want to know it in radians, what's the whole circle? How many radians in one circle? 2 pi. So if they want to know it in radians, then you're going to multiply times 2 pi when you do the whole. You need to know those two. Then now there is no whole well, actually there is a whole circumference, but you have to solve that out. It changes depending on the circle. Because the size of a circle, the bigger it gets, the bigger the circumference gets, because it's a measure of length. It doesn't matter how big a circle is, it's got 360 degrees. That never changes. Doesn't matter how big a circle is, it's always got 2 pi radians. Again, if you missed the last lesson and you need to go back and watch the video, otherwise you're going to be completely lost on, especially on radians. So the percentage times the whole. So I know the percentage, right? I need to figure out the whole. What would the whole be? No, because I want to know the length. So what does length mean? It says right there. So I need to use, what does it say when I say length? So I need to figure out the whole in this case is going to be the whole circumference. So I need to use the circumference formula. 2 times pi times r. Well, I know r is what? 10. I gave you the 10, right? So 2 times 10 is 20 times pi is what? And remember we said use the pi button. So 62.83 is the whole circumference. So if that's the whole circumference, I only want 13.9% of that, because that's how much of the whole circle that blue line is. So I just say 13.9% times 62.83. So 8.73-ish. So that length right there is 8.73 units long, whatever the unit would be, meters, centimeters, inches, millimeters, whatever. Holy cow, look who's here. Yeah, have you tested yet this week? Did you might have missed your day. I think I did see your name on there one day, so they'll probably call you out next week. What did step 3 say? And these are your instructions. If that doesn't make sense to you, you need to change them, and you need to say multiply the percentage times the whole, and say multiply if you need to see the word multiply in there. But that's for this lesson. That's your process. Even if it's radians, degrees, or length, which it was in this case. Yes. Oh, I said 8.73 right there. I mean, you might have gotten something a little bit different depending on where you round and everything. All right, so that's your exit ticket. That's a quick review. And then mainly, I just wanted you to add that into your steps. Or if you didn't get the steps, if you weren't here, those were the steps. All right, so now let's go to, yes. Well, we got to go on, girl. What did you get? I mean, you missed the lesson the other day. I can't redo the whole lesson today, but what did you get? Oh, was it close? Because like I said, it can be 8. Say it again.
8.
I think, yeah, I don't think you did percentage. I think you just did 13.9 maybe. Still a little off, but sounds like mostly just that. So we did radians last time. Again, same exact process with radians. It's just at the end, when you say percentage times the whole circle in radians is 2 pi radians. I'm not going to go back and explain what that means. You can watch the video. If you didn't understand it, watch it again. Look up other videos, whatever you got to do. But just if you just accept that if they're asking you to find the measure in radians, the whole circle is 2 pi radians, then you're fine. I don't know if we said it in this class, but if you multiply it out and get a decimal, typically your answers are going to not be in decimals. They're going to be something like this: 2/3 pi, 1/3 pi, 2/9 pi. Like they're going to have pi in the answer with a fraction. Or it might even look like this. This right here is the same thing as 2 pi over 3. So instead of trying to figure out what matches up and how to change your answer, just convert all of these to decimals. Just say, well, I just need to take 1/3, and you put ABC, 1 ABC 3 times pi. And actually, I don't even think you have to say times pi. I think you just put, Hal, put it up, bud. So we do not touch technology in here. So when you bring it to my attention, then I start checking for stuff. You're going to ruin it for other people that are getting away with stuff like earbuds. So just please don't do that in this class. You're not at that point yet. And this is the hardest stuff we might have done all year long, other than maybe proofs. 1 ABC 3 times pi will give you the decimal. Then just compare that decimal to your answer. If it's the same, then that's the right answer. Again, 2 ABC 3 times pi gives you a decimal. Compare that with your answer. And they will never have 2 possible answers that are so close to yours that, you would have to choose between 2. Like you wouldn't be able to figure it out. Even if you round, they're not gonna be anywhere near each other. All right, so we got to do one more problem. This will kind of be a review, I guess, that we didn't get to. Look at example 8, and I don't know what page that is. see. Example 8, that's page 206. So maybe like page 203, 204. So somebody tell us what page it's on. 204. Can we look at example 8, page 204? I still don't see it. Example 8. That's example 4 there, so that's not it. Wait, what? Oh no, those are practice problems. I'm sorry, never mind. So it's farther up, I guess. Yeah, here we go. Example 8. All right. Oh, that if you weren't here, those are your problems you're responsible for on the quiz from the lesson you missed. 205, 206. Again, I don't check anything, so I'm not saying I expect you to do 41 problems, but I'm telling you I expect you to know how to do them. You do 2 from each section and you feel like you're good, then that's fine. But that's what I expect you to know. All right. I think I can get rid of that. Yeah. So find the length of ZY. So this is a little bit of review of everything as well as a new example that we didn't do the other day. What's the first thing that jumps out at you reading that question? Could be one thing that jumps out. Well, it should be a couple things, but just without even looking at the picture, what jumps out at you reading the question? What's that?
Pi over 4.
Well, I was just talking about the question, but the fact that we have a pi and a 4 is something special. But what else? To do with our steps that we wrote down a second ago. Question. Length. So what does that mean we're going to use? We're going to need circumference. It says length, the only measure of length. Unless it says, and I don't even think they'd ever do this, but unless it said the length in radians, then that would be different. But I don't believe they're going to do that. Hopefully not. So if I'm going to need the circumference, I could just go ahead and solve for that. What information did they give you that you're going to use to find the circumference? Nayland. There's a lot going on in this. 9, right? That's the radius. So that's the radius right there. So if that's the radius, I'm going to want to probably use the radius formula, the circumference formula with radius in it. So I'll let you guys solve that out real quick. Actually, I'll solve it out real quick. You should all have a calculator. Oh, Ben had one. What's that? Yeah, Ben had one. A couple of Ben recording also. Both recorders. Oh yeah. No, I know you got to go. So for the circumference, 18 pi is one way they might show it. Just remember, I don't know how the state actually makes your EOC, but you might even have to take a district assessment before that. You know how we do that sometimes. They a lot of times leave pi in answers. Like they just say, well, the circumference is 18 pi. They don't multiply pi out. So just understand that's just a number. Just means I haven't multiplied the 18 times pi. If you do multiply it and get a decimal, you get 56 point. I'm gonna round it off to 55, something like that. Again, you got to be a little careful when you round off, but it's not as important as this because we're not. Yeah, that's right. Radius is from a point on the circle to the center of the circle. Yeah, that's how I got 18. 2 times 9 was the 18, and I just didn't multiply pi initially, just to show you that sometimes they leave that in there. A lot of times when you're dealing with radians, so this means radians. When you see pi in an answer, that means radians. So you do need to understand that. You need to write that note down. When you see pi, like the measure of that angle is not in degrees, right? That's normally how we've always seen the measure of an angle is in degrees. That's not in degrees. So that means the only other measure of an angle is radians. If a whole, how much is a whole circle in radians? Always, so what is half a circle in radians? Just 1 pi, right? So if you think of a semicircle, half a circle, let's color coordinate this red arc, or you could say the angle. What is that? And again, we could say this angle here in degrees, what, because they match, right? Central angle matches the arc. What is that in degrees? Yeah, it's half, right? So you should all, that one's just a little more intuitive. You know degrees. It's pi radians because it's half of the circle, and we know the full circle is 2 pi, 5 by 2. So that's another measure that can kind of help you understand maybe a little bit. So 3 pi radians is short of 1 pi, right? It's 3/4. But it should be short of a full, or I'm sorry, it should be short of a half of a circle, which it is. It's actually right in the middle of 90 and 180. So again, if that helps you to understand a little bit about what you're trying to figure out. So if we are figuring out the length, and we know the full length is 56, what length would we guess would make sense? What were you even doing in that? I know a full circle is 56. Clearly, I can see that's not even a half circle, but you know, it's getting kind of close to a half. I want you guys all try to figure out a guess to it. Don't say it out loud. Please watch. This you can pick up enough to retain. What would you say your guess is? Who am I going to call on for that? Chance. You look like you're diligent for it.
I'd say somewhere around 18.
18 to 20. Well, what would half of 56 be? 28 is half, right? So it's got to be less than that. We can even just visually see it's got to be less than half. I could figure out 1/4 of it because I know 1/4 of it is 90 degrees, right? I took 1/4 of that number. So actually, what would 1/4 of that be? So about 14-ish. So somewhere between 28 and 14, pretty close to the middle of that. So somewhere around 20, 21 would be kind of how you could say, before you do the math, I should get an answer around here. If I don't, I need to check my math. I probably did something wrong. So now we just say, okay, what's our first step? So again, we go back to our 3 steps. What's our first step? What percentage of the circle is that? That's the tricky part when you're dealing in radians. Again, I know it's less than half. I know it's more than 25% because 90 degrees would be 25%, right? If I had a 90-degree angle in a circle, that's 25% of the circle. Well, my angle is bigger than that. It's smaller than half, so it's less than 50%, more than 25. So again, it's going to be right in between those two, like somewhere around 40, less than 40. Let me go backwards and get rid of that. So here's the question. How do we figure out percentage of a circle? It's the same every time. The numbers will be different, but the concept is the same every time. Vanessa, how do you figure out the percentage of the circle? And I'm going to help you. I know she weren't here, but I'm picking on you. I know you're going to get this right. How do I figure out the percentage of anything? I want to know the percentage of girls in here. What do you do? Just don't have to do any math on it. What would you do? Percentage of girls is what? Based on how many what's? I mean, you gotta use one number. If I want to know the percentage of girls, I gotta figure out how many what? How many what? So I need how many total, again, I didn't say students, but we'll say student. I need how many total students, and then what's the other thing I need? I'm gonna figure out percentage. What did I ask you for percentage of what? So if I know the total, I need to know how many what? Girls. I need to know how many girls, right? That's the percentage I'm figuring out. So it's a part divided by a whole. It doesn't matter that it's in radians. Still the same concept. I need a part divided by the whole. The part is what they give you. We're used to them giving us degrees and we divide by 360. But in this case, they're giving us radians. So the part, and it gets a little tricky, but just use your calculator. That's the part. What's the whole if I'm talking about radians? 2 pi. Now, here's where I don't think you can use the ABC button and do all of that in using the ABC button. So you might just have to multiply it out and then round your answer. Not till I finish this. So if you multiply 3/4 times what? And really, so again, if you don't understand what I'm about to do, just multiply everything out. If you're dividing pi divided by pi, what's that gonna be? Well, not nothing. It'd be 1, right? So I don't really need to even use pi. I'm really just saying 3/4 divided by 2 is really all I'm saying. That, I don't know if you can do that. Well, you could do 0.75. Did it work? So with the ABC button. So you put in what? Like you literally did 3/4 and then pi and then said ABC. How'd you do it?
I did.
Okay. And then divided by and then 2 pi is pretty simple. Oh, I didn't get the right answer. I got 3.701 if I just did 3/4 pi divided by 2 pi. Huh? Oh, that's not right. Because now do 0.75 divided by 2. That's what you should get. Let's see if 3. Let's. I don't. So I think the only way to do it, the best you can do in the calculator, again, if you understand that pi just kind of cancels out, you could do 3ABC4 divided by 2. That's about as short as you can make. And that gives you 3/8, which, like I said, sometimes they're going to give you answers. So 3/8 is the percentage of the circle in a fraction. If I convert that to a decimal, so now do this. Here's the long way to do it, but it will always work. Just multiply, convert this to a decimal. How do you convert that to a decimal? So do 3 divided by 4 if you don't already know what it is. Some of you probably already know. So then take 0.75 and multiply it times pi. And you'll have to write some of these down if you don't know how to like store it in the calculator ways to work it. So what do you get when you multiply it times pi? You say a few numbers, 2.35. Well, I want more. I want several numbers. 561. What was after the 1? Do a bunch of them. I just want to, again, where you round off, the longer you make the number, the more accurate it's going to be. The shorter you make it, meaning the earlier you round, the more chance that it's not going to match a multiple choice answer. I don't care for my quiz. You can round it wherever you want, really. So now that's going to be divided by, now say 2 times 5. Let's quick fast one. Actually, I can probably 6.2830, I think.
Yeah.
So now say 2.56194 divided by 6.2830. This 3/4 times 5. Times 5. Because if this is what this would look like in a fraction, you'll see in a second. So what do you get when you get 2.5 divide 2.56194 divided by 6.2830. It would round it up. Oh, well, you can change. I don't think that'll change it. Yeah, if you want to try it again. Holy cow! Look at this. There you go. I can't read it. Huh? Who is that? Who is that? What'd you get? 4 zeros. Oh boy. Oh yeah, boy. Nobody caught that. This is the wrong number. I missed apparently when I wrote it down. You said a 3 before all of that. So I caught the 56194, but there was a 3 in front of it that I didn't hear. So we don't really need probably the 4. So fix that real quick. Do the math myself, I guess. Here. So 2.3561 divided by 6.2831. So you get the decimal you would have gotten is 0.37500, and then after the zeros, there's numbers behind it, right? If you multiply everything out, so you converted this to a decimal, multiply it times pi. Here, you didn't have to convert it to a decimal, you just multiplied it times pi. Then you put a few numbers behind the decimal and rounded. If you didn't round at all, you get that. So it comes out to be the same number. So you can do it either way. The ABC button is more accurate. You understand how to say 3 ABC4 divided by 2. If you understand pi isn't really necessary because pi is in both the numerator and the denominator. But if you don't understand that, just convert everything to decimals. It'll work. You could do that also. You could say you could say 3 ABC4 times pi, and you'll get to this 2, and then you'll say 2 times pi and get to that. My point is, do it whichever way you understand. Fractions is best if you want to work a little bit to understand that. If you just really understand the decimal way, just understand you could possibly have rounding errors unless you write a bunch of numbers after the decimal. So don't round early if you're going to do the decimal. All right, so that right there is what? What is that? 0.375. I forget. Alyssa, what is that 0.375? That is the percentage. It's the percentage as a decimal, but it is the percentage. A decimal is just a percentage. We use that to create the percentage by just moving that decimal 2 to the right. So it is, so that section, let's do a color. This yellow arc is 37.5% of the circle. So again, our first step is what percentage of the circle in all of these problems. So I haven't even gotten to the new stuff yet. We're gonna have to fly through the new stuff. Now and we already figured out the circumference. We already did step 2. We saw length, so we figured out circumference. So what's the last step? It says intercept. Yeah, percentage times the whole. So we just take 37.5% times, that was my whole. So somebody do that for me I guess I should do it since Struggle sometimes to write down the correct number. So 37.5% times 56.55. So we get 21.2, we'll say, is how big that yellow line is. So that yellow line is 20, what did I say? 21.2. Is that what I said? 21.2 is how long that yellow line is. Again, followed the same exact steps, even though they gave us the beginning information in radian. Steps did not change. It's just when we figured out what percentage of the circle, we had to use radians for our part divided by our whole instead of degrees like we've been using. Any questions on that? Now I'll let you go. Unfortunately, we gotta move fast. I would love for you to have practiced an example. Well, that wasn't an example, but let's go to 10.3. So turn to 10.3 real quick. Yeah, lesson like page 209, 10.3. This is actually a pretty short one. That's why I didn't like the lesson is shorter than most lessons, so that's why I didn't rush through the last piece. And the last piece, if you don't, again, that's kind of like the building block. If you don't understand central angles and percentage of a circle and all that kind of stuff, nothing else we do is gonna make sense. So we need to spend some time on that. All right, so we've already talked about some definitions. What is a chord? Chord. Mila, what's a chord? Yeah, the endpoints of a line segment that are, well, the endpoints are on the circle. So it's a line segment. Those 2 points are on the circle, and we just connected it and made a line segment. That's a chord. So that's a chord. JH is a chord. The diameter is a chord. If they give you the diameter problem, the endpoints of a diameter are on the circle. It just happens to be a chord that goes through the center of the circle. All right, so I'm gonna just kind of cover this. I can use that picture, that's fine. I was gonna go to my own picture, but we can use it. I just have to zoom in. So look at theorem 10.3. I'm gonna zoom all the way in. That's probably large enough. So this is a theorem. Theorem means it's a true statement. This will always be true. If you have 2 chords in a circle, and those 2 chords are the same length, so we could, I don't know that they put congruence marks in these types of figures, but they might. If those line segments are the same length, then the arcs are the same length. So that arc is congruent to that arc. So that's hopefully relatively intuitive. It's kind of, anyway, there's nothing I can think of. I told you circles is, a lot of it's just brand new. I can't even think of a way to compare that to something that we've done. So for now, I'll see if I can come up with a way. For now, just understand it's kind of like that line segment is taking up a section of the circle, just like the arc takes up a section of a circle. But for now, just understand if the line segment is congruent to another line segment, then the arcs that have those same endpoints are also congruent. Same number of degrees, same length, same number of radians, whatever measure you use, they are the same. And it would go backwards as well. If the arcs are congruent, so if we knew this was congruent to this, then we would know the line segments have to be congruent. So it goes both ways. Line segments are congruent, arcs are congruent. Arcs are congruent, then the line segments have to be congruent. So that's your first theorem. And again, these will seem easy when we do them one at a time, but then you get a quiz with all that stuff on it, that's when it gets tricky. If we have a diameter, so AB is a diameter. If it is at a perpendicular angle to a chord. I was gonna say line segment, but we can say chord. It is a line segment, but it's really a chord. X and Y are on the circle. They're connected to create a line segment. So if you have the diameter and it is perpendicular to a chord, then it bisects that chord. So if you see 90-degree angle there, and you know it's the diameter, then those two little segments are congruent. And it would go the other way. If we knew those two little segments were congruent, then we would have to say, okay, well, then the only way that can happen is if it's at a 90-degree angle, if that angle is 90 degrees. Again, assuming it's the diameter. If it's not a diameter, that's not true. It doesn't go right to the middle of the circle. Like if I had a line here, so there's that, but then I drew a perpendicular line down here. Well, obviously that doesn't bisect. It might be at a 90-degree angle, but it doesn't bisect that line. Because again, that's not the diameter. It has to be the diameter that's at a 90-degree angle to the chord. Make sure you understand that. It's not just because I have a 90-degree angle. It has to be the diameter. And again, all this is in the theorem, so. And I'm sure the next one is just saying the opposite, probably. Yeah. If I know I have congruent segments and a diameter, then it has to be a 90 degrees. So again, it goes both ways. No, it's 90 degrees, then they have to be congruent. If I know they're congruent, then it has to be 90 degrees. All right, so now 210. That was it on that one. We got one more. And then we'll do some examples, and then hopefully you'll have a minute of practice for the exit ticket. So if I have two chords, here, let me zoom in more. I mean, you can look at it in your book, but I'm still going to zoom in. I guess I have to do it over here. That's all I can do. All right, that's again, you have it in your book. So I have two chords. I know that those two chords are the same distance. Remember, distance is measured at a right angle. That's why you have the little right angle symbol in there. So I know they are the same distance, right? That line segment is the same length as that line segment. It represents distance from the center. If they are the same distance from the center, then they have to be congruent. So that line there has to be congruent to that line there. And then the opposite would be true. If I know that the two line segments, the two chords are congruent, then they have to be the same distance from the center. I mean, all these things, they all are the converse. So two chords, I shouldn't keep saying line segments. Two chords are congruent. We know a bunch of things right now. Just going to review. I know if the chords are congruent, I know that's congruent to that. Well, then I know that the arcs are congruent. That arc is congruent to that arc. So again, if the chords are congruent, I know the green. I know that they are the same distance from the center. So and again, all these things have converses. If they're the same distance from the center, then the chords are congruent. If the arcs are congruent, then the chords would be congruent. So I can go either direction with these things. As long as you just remember all three of those things, you should hopefully be able to figure out what you need to do in the problems. So that's the three concepts, the three theorems. I want you to try to do, if you need, in this case, again, I tell you typically, don't look at the solution, only look at the bold, because that's truly all you would get on a quiz is just a question. If you need to, like, if you just can't figure it out, then try to see what they're doing in the problem. And then you can try the check problem and then after you go. So try to do example 1. Actually, just go ahead and try to do example 1 and example 2, which I guess on page 211. So example 1, check problem. Example 2, hello. I'll give you like, that one should not take any time at all right there. That one, yeah, I mean, there should be no problem with that one at all. If you're struggling, then go back and look at the 3 theorems we just went over. That's straight from one of the theorems. I'm gonna have to zoom back out, so. See what example 2 looked like. It's oh, that's 3. Where's example 2? Oh, there it is. I guess example 2 is on the same page. It's covered up. Let's see. What does that symbol mean? This symbol. What does that mean? Yeah, that means congruent, right? Congruent. That means they are the same measure, the same length, depending on what they're talking about. Find FG. All right, that's pretty straightforward. I mean, you gotta do some algebra on it, but the concept is pretty straightforward. You should, if you go back and read those theorems, and I'll help you in a second, but you really should be able to figure those out on your own. The theorems. Cut A. Focus. Yeah. Yeah, but you need to be trying this, even if you're just doing it in your head or. Here, I'll let you do what some of my kids in my other classes do. Yeah. How about Sure. I'm doing that too. Or on paper, I don't care where it looks.
I want to do it.
Well, you won't, just remember, when you do that, you don't have it for later. What color do you want? Purple, orange. Purple, orange. Again, you don't have any notes if you do it on your desk, but better than somebody sitting there and not doing it. Right, Marcus? We have figured it out, but.
Okay.
Dan, I've lost them already. We just throw them out. You should just keep them in here. Why don't you just keep them? I'll give you a. Yeah, folder, you put them in a folder. Keep them in here. That's when I sit down, I get it. Really, and I would get them before you sit down. So example 1 and 2 come straight from the 3 theorems. You just gotta figure out which theorem matches which example. Did you not page it out? I don't remember when we tore them out. You gotta have pages. It was last week, right? The last week. You gotta have pages, bro. You're not new. Yeah, I'm not gonna worry about it right now since you're sharing, but you have to find those pages. Yeah, I don't know how you expect to be successful in this class when we literally do everything straight from the book. Oh, I did pass worksheets out, I guess. Again, actually, I'll go ahead and give you a hint now. So on this one, I don't know what happened there. So on example 1, it says that didn't work at all. Yeah, let's get rid of that. Thought that was gonna stay sized with it, but it didn't. So it says if I know line segment JK is congruent to LM, they are congruent. What's true? Then the arcs are the same. That's it. And they tell you what one of the arcs is. You better be able to finish that problem. So I know, and that was the first theorem we did, I think. If the line segments are congruent, the arcs are congruent. If the arcs are congruent, the line segments are congruent. And you don't even have any math in that one. And then you can do the check problem right after that, same concept. Now they didn't, here they gave you it in text. Here they just give you a congruent symbol, but same concept. Then example 2, it's the same concept. It's just you gotta do more algebra. If they're congruent, then that means they are equal. That's your equation. You set them equal and solve. Which is typically what you guys do anyway, even if it's not. I gotta remember who came in late. Late, gotta change your attendance. That one good girl. Anthony with the testing, but came in late. Attendance. I can't remember if had I done attendance, do you know for sure? I think Jorvik may have been. He wasn't in class, but I had seen him, so I counted him. Just Anthony in. All right. I'll still change it, just to make sure. Yeah. Are you in trouble?
No.
Oh, you don't have to tell me. I'm just teasing you more than anything. You know how like every time somebody gets called out, the kids like, especially when you're young. Ooh. All right, so again, example 1, pretty self-explanatory. If I know, and they do actually give you the marks, I didn't even notice that. If I know those two line segments are the same, I know the arcs are the same. So if that's 75 degrees, that's 75 degrees. That's all there was to that. No math even involved, just you had to understand the concept. Same thing down here. If I know that those two I shouldn't say segments. Those two chords are congruent, then the two arcs are congruent. That's all there was to it in those two. So that would be, if that's 60-degree arc, that's a 60-degree arc on the bottom. Now concept is the exact same. I just have a little more algebra to do. So it tells me these two arcs are congruent. Well, if I know the arcs are congruent, then I know the chords are congruent. Like I said, it's the converse. It goes the other direction. We're going backwards. So if I know the chords are congruent and I want to solve for x, what does congruent mean? I heard same length, right? So if this chord, and what does that represent? What is that thing? That is the length. That is the length. Doesn't matter that it's got 2 and x and 6 and all that. That is the length. This is the length of that chord. So if I know the chords are congruent, meaning they are the same length, then I just set those lengths equal to each other. And now you solve for x. So if you solve for x, looks like you get x equals 5. Can't be negative 5. X can't be negative. Well, actually, x could be negative, so that's not exactly true. I think you just like got something wrong with your negative. Oh, did you do a negative divided by a negative? Oh no. The negative divided by negative changes to positive.
There's the,
That's negative 15. But then you would be subtracting, that's negative. Oh yeah, you did do a negative. You just forgot to put the negative there. A negative is, right?
oh, yeah.
So yeah. So just be careful now. So that's actually a good point. If you're solving for length, the length itself cannot be negative, but it is possible that if you're solving for x within the equation, x could be negative. X is just a variable. The length, though, always has to come out as positive. So if you plug that negative x back in, you better get a length that is positive, even if x is negative. I doubt that will come up. Typically, they'll just make everything positive, but try to do it again. It's just really doing the algebra. Do the check problem real quick. I'm not going to do it. We're just going to compare the answer on it, or make sure you got it right. I'm going to go ahead and move on to example 3 while you're working on that. So if you're done with that one, you can just kind of go to example 3. And let's see, you really should be able to do all of these. None of these are super complex. You may have to go back and look at the theorems we just did. All right. So we have, if you think it's complex already, wait until next week, the circles. So actually this quiz shouldn't be too bad either. Relative to what's going to be covered in the future. Oh, so let's see. So arc 120, EFG is 120. Find arc FG and EG. What? Huh. I do not like the way they worded that problem at all. Huh. Oh, wait, it's line set. Okay. So that's important. I don't know why I put my cough drop up there. Yeah. No. No, no, no. No, this is stuff you gotta get down, bro. You can't shut down. Which one are you on? Well, if you don't know how to do 3, yeah, we'll go over that. But were you good on 1 and 2? Okay, then you're fine. Again, I'm gonna give you hints on this, but I don't necessarily expect everybody to know how to do this one start to finish. I'm just saying you should be able to understand it after we go over it. You may not know how to do it. Oh, no. Oh, did you didn't? And somebody else used it with spray, didn't she? Yeah. Yeah, I'll give you, I meant to do this earlier. If you use that, use the paper towel. I mean, still use the spray, but also. No, the exit ticket is something different. You unfortunately have missed all the lessons on the exit tickets. Technically, this is the only one today. We did different on the quiz on oh yeah, I forgot to mention that. I'm not giving you 2 different grades for this exit ticket. If you already got a 100 on it on the quiz, you don't get another 100. It's the same exact question. I didn't even change. Like numbers are the same thing. Yeah, remember I had one problem at the bottom that said exit ticket. We literally did that lesson the same day, right before the quiz. So if you get it right again, then at least it means you retained it. I haven't graded all of those. I haven't graded any, well, I graded a few in first grade. All right, so let's go ahead and start going over. So we have this information, and here's what did we learn about this typically? When it's giving us an arc like that, what did I tell you? What did the book say? It's coming from the book. What did we say when they name an arc like that? What? The book said major arc when we had 3, right? Like that was the way we distinguished between the minor and the major. That's not a major arc. So why they named it with 3 letters, I don't know. I mean, you can still see where it is because you go from E to F to G, so you still know it's that arc. But why they're changing around what they told us in the naming, I don't know. Like they should have just named that, in my opinion. They should have just named it arc EG because it's a minor arc. They didn't. Doesn't affect the problem at all. But I wish they would have stuck with the way they did at the beginning when they named them. So we know that arc. That's why I erased it. That arc is 120 degrees. What percentage of the circle is that? We don't need that. Thinking that. 1/3, right? 33%. So now, unrelated, we also see that guy there. See you later.
I gotta go get my ice cream breaks with testers.
All right. So we also see that right there. What's important about that? So what theorem are we talking about here? Which one is that? So it is the bisector. Now, but what did it say in that bisector theorem? That we don't have. Diameter, right? Do you see a diameter? So is it still that theorem? Because I like to see your reaction. You don't really. So here's the thing. Isn't the radius, isn't that just half a diameter? Like, couldn't I then draw in straight through to the other side and make it the diameter?
Yeah.
So again, you don't really have to have the diameter. It is a true concept that the diameter needs to be perpendicular. But if you have a radius that is perpendicular, that's the same thing. It's just half a diameter. So if you have the radius, that also works. The key is it has to go through the center of the circle, which are both a radius and a diameter. That's really what you do. So with that in mind, now I know it's a bisector. So if that's 3.5, I'm assuming it asks for HG. Oh no, it asks for EG, so kind of the same thing. So what is HG? So now I'm going to get rid of all of the writing so you can see if I can't zoom in anymore. So if that's so the 3.5 is that segment there. It's also 3.5, right? It's a bisector. We just said that. And they ask us for the entire line. So what's the entire line? There, you just add them again. So again, that was the theorem that it was about a bisector. It's a little different in that we didn't have a diameter, but
This might be a step ahead of it, but would we also be able to figure out the diameter from this side?
oh, absolutely. Well, yeah, absolutely. Hold that thought. Actually, maybe not. Yeah, maybe not. It would not. Because I thought we'd be able to do like a squared, b squared, c squared, but we do not have. Oh, here's a good question. What's the measure of arc FG? Yeah, it would be bisected also. I didn't see that. They didn't say anything about the arc being bisected, did they? But the arc would be bisected because if the segments, and again, I don't know if you can even say, does it? Oh, it does, okay, so it does say that. So the arc is also bisected. I'm surprised they didn't put that in the problem somewhere, but the arc is also bisected. Oh, they do have it down here. Oh, they do have it there. Yeah, what is FG? I'm sorry, they do have FG there. So yeah, they do have it. So the arc is bisected. The line segment is bisected and the arc is bisected. So I'm glad to talked about that. The arc is bisected and the chord is bisected. I'm not going to go over this one. It's pretty much the same exact problem. You can try to do it on your own. PR, yeah, it's the exact same problem. So let's go down to example 4. Now, this is one where you'd be able to figure out more information because they gave us the length of the radius in this. And the other one, they didn't give us the length of the radius. Well, technically, they didn't give us the length of the radius. So I want you to look at example 4. I am pretty sure that is on your quiz Monday. I feel like that looks super, super familiar, which normally means I took it and put it on the quiz. I see a diagram. Now they already created kind of what you needed here, and I would make you create that. I wouldn't give you that piece, but you would only have, all you would have is this right here. Then you'd have to create the drawing below in blue and install. So do as much as you can. Again, I don't necessarily expect you to be able to work this one all out on your own right now. But I think after we go through it, you should understand the pieces of it enough to certainly get started in partial credit. And this lesson will be the last lesson that's on your quiz Monday. So basically it'll be through, what is this, 10, are we in 10.3, I think? 10.4. Oh, did I write your problems? You're right, there's up. I really don't want you to go right in the middle of this one, so let me see it. Let me let you go after me. You're set. So I'll get started on this one in a little bit. I'll start this one in just a second. Can I zoom in anymore? I think I'm already fully zoomed there. Yep. That I don't think I can zoom in more here. Oh yeah, I can. Oh yeah, that's perfect. All right, so there we go. So again, you would kind of have to be able to create this yourself from that, or you can just create it right there. I'm just going to write it right over the top of that. So it tells us the record shown can be modeled by a circle. So that's what they did. I'm just going to do it right on the record. It says the diameter CD. So they give you that. So that's pretty easy. CD is 12. I'm not going to write the 12 in there. Just know that yellow line is 12. Because here, I'll circle it. So that's the yellow line, the diameter. What does that tell me immediately? Before I go any farther, this is, I would say, the process you should go through. I'm going to call him Zoe. I'm going to call him Zoe. Before I even read any farther, I know the diameter is 12. What can I do? What should I probably do? Something else you should think of as soon as you hear diameter is 12. Got it. Tell it. Yeah, radius, right? I know the diameter is 12. Immediately I think, well, then the radius is half of that. So I'd go ahead and write. They have, oh yeah, they do have a point there. Let's see, we can do black point for that. So if they have a point there and it's CE, as soon as I see that, then I know that. And I could also write ED is also 6. Like I said, don't read the whole problem and then start trying to figure out the answer. As soon as you read something and you go, oh, wait a minute, well, that means this is true, then write that. That way, when you go back and try to figure the answer out, you've already done some of the pieces that they didn't give you. All right, so we know those two things are true. Now it says chord FH. All right, well. So FH is, what's it say? 10 inches long. I'll put the measure, 10 inches. Oh, I'm sorry, chord, you're right. Yeah. Oh, arc. So yeah, let's resolve that. So the chord is 10 inches long. Yeah, there's no arc. I don't know. I could have sworn I saw an arc symbol, but no arc symbol anywhere. So I know that is 10 inches. I guess they don't really say anything in here, so I guess the only thing we are supposed to recognize, and it's real. So I'm holding somebody's. Don't they go anyway? Talk about bathroom? Yeah, no, you gotta wait till after the other goes, which means probably me. I guess you just have to see that it's really lightly written. I could barely see it on mine. Hopefully it looks more obvious in yours. So if I know I have a diameter, I know I have a right angle, what does that mean happened? Yeah, bisected. Bisected the arc. So that's also bisected, but it's not about arcs. So that is congruent to that, which means what is FG? What is GH? There you go. And now that's probably everything I need. Blue. So I'll just write over here. F G 5 G H 5. That's all the information I have. Now let me go back and see if I can figure something out. So I need EG. I need, oh, this is kind of a good one. I like this one. Like blue, maybe? Yeah, that's good. So I just want EG, which I didn't solve for. I haven't gotten that yet. Right? So I do have to do a little bit of math. What do I do, Isaiah? So yeah. Well, now say that again. Now we can't say that. We can't say FH is bisecting the diameter. Doesn't go that way. The diameter bisects this. But that, because I could slide this down, right? I could move that anywhere and it would still get bisected. There's something tricky. If you look at the picture they did, that's kind of your hint. And you may, this would be a very difficult question, but I think it is on the quiz.
It's right triangle.
That's what it is. I know the length of that, right? I also know the length of that. How do I know the length of that?
Because that's the diameter.
Well,
Radius.
that's the radius, right? We said earlier, we just talked about this CE being, what did we say? CE is 6. ED is 6. But every radius is 6. So this blue line is also 6. I know that's 6. I know that's 5, we said, right?
Yeah.
So I know 2 of the 3 sides of a right triangle. Because if that's a right triangle or a right angle on the right, it's a right angle on the left. That's what we have to do to solve that. And again, I'm pretty sure that's on your quiz. So make sure you practice. You can do the check problem in a minute. When you go to the practice problems that I assign, you'll go to example, like the section that says example 4 will have similar problems. So go ahead, solve it out. Would that be 36, subtract 25 less? So should get 3.3, 3.4-ish, something like that.
3.3.
3.3. So So the answer again, we saw for that little blue section right there. Oh, that's not dark enough. So go ahead and write 3.316, you said?
1.6.
Let's just round that to 3.32. So if you write that down, you can try to finish it out. If you didn't, I think there's one more example and then we're done. Uh-oh. Uh-oh. What's that? Oh, actually, I think, oh no, here we go. So again, chords equidistant from the center. All right, that's fine. This is simple. Equidistant. So all you gotta know is the concept, right? If they are equidistant, what is true? I see that. They didn't give me congruence marks, but I see that's the same number. What's true? Not bisector. That's got to be a diameter. So it's the other theorem. What was the other theorem? Remember, just remember, it's got to be a radius or a diameter to be a bisector. We don't have those in this. Yeah, the chords are the same. So if the chords are the same distance from the center, then the chords have to be the same measure. So you're gonna have to memorize those. This is not a quiz where you can just say, yeah, I got it all. You gotta go back and memorize so that means QP is the same length as RS. So we just set them equal to each other. So 3x subtract 4 equals 14. They're the same length. That means their lengths would just be equal to each other. So here's your problems that you have to do. On page 213, the entire page. So what is that? Through 14. So 1 through 14. And that was 213, I think, right? On 214, just 17 and 18. Wait, that's missing problems. That ended at 14, didn't it, on the other? Oh, did it? Oh, yeah, I can't. You're right, 13, 14, 15, 16. So yeah, so then on the other page, just 17 and 18. So basically 1 through 18 on 2 different pages. And that'll be everything for your quiz on Monday. And hopefully you wrote down the other thing I had up, page 205 or 204, 205. I'm going to go back and show you. So, and remember, it's recorded also. Oh, 205, 206. All right, I'll change that. Whoa. Look at that. Yeah. Hold on. All right. Well, 205, 206. Hopefully you wrote it down earlier. Put all your stuff up. Oh. I didn't think you super well. Okay. Thanks, dig it. I'll get it. Some of you already got it. Probably not the quiz. You need to like stay a minute or two afterward. That's fine. You separate that for me, please, and I'll take it from you here. You, and we'll do This might be in his last volume.
Actually, just. Page 206. It's really just a word problem. We could read it. It's not saying. Oh, there is about 20 of 206. It's bigger to the right and bigger to the left.
So I still got 3 minutes of class time, and then, like I said, if you don't get done, I can send an email to. Oh, that was in your, that's why it's in your last. 205, 206. And there were 3 steps. I remember the 3 steps. Remember the 3 steps? Probably. All right. That's one. Anybody over there done? You're still working? All right. I remember the 3 steps. Okay. Oh, did you? On your desk?
Yeah.
You already erased it? I need work. Need work, bud. Whatever you're plugging into your calculator, you need to be writing it down. It says, write it, show your work. You keep working, keep working. I'll send an email out. If you don't know it, then we don't know it. And if they remember how to do it, I'm not. If you turn in a blank, put in a blank exit ticket, I'm not sending an email if you're just sitting there and you don't find it technically. Thank you. Oh, yeah, make sure your name is on it. We got to put a spot for name on it. Make sure your name is on it. It's 4.4. I just go to 2.2. Yeah.
What can I
We're laughing.
This time.
You did something. Have a nice day. All right. It's funny. You remind me of this.
I'm most likely.
Character in a movie. Why are you did stuff?
Oh,
What? I thought you said you did stuff.
I did.
Oh, look at here.
Because the local Peter went away from the office, but ability. If you get the website, huh? I went to let they're lifting on it. Well, but I mean, like, you showed up at the end, like, I don't think you're absent.
Alright. Yeah, I mean, you're only here for 10 minutes, that's.
No, where, I gotta catch up on.
There's a whole bunch of stuff you gotta catch up on, but I mean. It's
I'll probably
book
get
pages.
I know.
You have the book pages? Cause I never got a book.
I didn't, you tore book pages out one day, right?
I don't have a book.
I don't, we don't find a book, everything was out.
What's what to get
You
my
were
book?
here- you were here when we put the page out?
What's what to get my book to the laptop?
It was warm.
Yeah, I'm one from your other class, and yeah, I get that, then you have your own books. Otherwise, you have to tear them out, by the time you tear them out. If you have a book. Yeah. Oh, then yeah, get the book, go into that class when you get a chance and get book.
Was it boring without me? Yeah, but it's like, no.
What do you mean without?
But I wasn't here yesterday.
You weren't here yesterday?
Bro, you're not funny. Not funny.
I was saying.
It was freaking boring. And my legs hurt. We had to wear the uniform.
Yeah, no, I saw everybody dressed up.
Oh my gosh, you know
Like a
how
whole bunch of kids
hurt
today.
my feet were hurting.
This card. Yeah, I'm sure walking around in those shoes. Actually, the worst is not even walking around in them, just standing in them is the worst sometimes.
Yeah.
Yeah, standing still is worse.
Man. What was it called? We were talking to this one dude. He's 24. And Master Chief goes talk about him. He's too old for y'all. Y'all need to leave him alone. Bro was
Oh, what's your
talk blocking.
What'd you just say?
Bro was talk blocking.
What? You?
I was
I don't know how that worked. And he was
I
too old
moved
for
out
you
my
anyway.
house. Anyway, after my games track, I went home. He wasn't there, so I threw all my stuff out the window. I said, "Mom, come over."
What'd you say?
And him and Jada were.
I said, then we went to racetrack.
All right, bye.
Yeah.
I'm going to class, bro.
Bro, you don't lie, you don't do anything there.
Yes, I
I don't know what to say.
do.
You have a quiz. Didn't you tell me you had a quiz on Thursday? This one right here, right? You told me you had a quiz on Thursday. I
I
said,
took
what
that
you
class
doing?
on. I took that class on Wednesdays. I gotta see.
Oh,
And
that's right.
That's right.
So, Thursday. Didn't you say you had a quiz on?
I don't know. I wasn't here.
You told me the last time I said, what are you doing in that class? And you said something and you said, yeah, we got a quiz on that. What is it? Maybe you said next class or something.
Yeah. Well, I'm looking.
Which you missed, probably. What? Okay. It's probably, she probably almost fainted. Well, I gotta stop my recording.
Always on my feet, guys.
That'd be.
Uh-oh. There we go.